questions. Will you recommend the Job Guide 360 interview guide to prospective job seekers?
Sure, I will. The guide is detailed and very comprehensive.
Okay, let's unpack this. We are taking a deep dive into one of the most critical roles in tech, quality assurance, or QA engineering. And, it's often misunderstood.
Yeah.
It's not just about finding typos.
Not at all. It's really about ensuring software is reliable, trustworthy. And our source today is pretty cool, actually. It's like an internal cheat sheet for HR, full of interview questions and guidelines.
Ah, okay. So it gives us the inside track.
Exactly. So whether you're thinking about going for a QA role, or maybe you work with QA teams, or honestly, if you're just curious about how software gets made reliable, this should give you a shortcut to the key ideas.
And the source itself is structured quite neatly, isn't it?
Yeah, it breaks things down into 3 buckets. The computer science basics, the specific day-to-day stuff of the role, and then the behavioral side.
Right. So let's start where they start. The fundamentals. Got to get the terms right first.
Absolutely.
Yeah.
Especially the big 3 that always get tangled up: QA, QC, and software testing.
Okay, yeah. I've definitely heard those used interchangeably. What's the real difference? Lay it out for us.
So the source defines quality assurance, QA, as the proactive bit. It's the whole process, the strategy, across the entire development lifecycle to ensure quality. Think prevention.
Before, during, after coding. It's the whole philosophy.
Precisely. Then you've got quality control, QC. That's actually a part of QA.
A subset.
Right. It's more reactive. QC focuses on checking the quality of the actual end product. Did we build it okay?
And testing.
Software testing is the action, the doing. It's the process of actually running tests to find bugs or defects in the product.
So QA is a strategy, QC is checking the output, testing is the activity.
Got it.
Yeah.
That distinction is super important.
Okay, sticking with core definitions, verification versus validation, another pair that sounds similar.
Yeah, and crucial for a QA engineer to understand the difference, especially when talking to, say, product managers.
How so?
Well, verification checks if the product meets the specified requirements, the blueprint, essentially.
Like, are we building the product right, according to the plan?
Exactly. But validation, that asks if the product meets the user's actual needs.
The bigger question. Are we building the right product in the first place?
Spot on. 2 different focuses. The spec sheet versus the real user.
Okay, that clarifies things nicely. Yeah. Let's move from concepts to specific testing types, the source flags as essential.
Yeah.
Starting with smoke testing. Sounds dramatic.
Yeah. It's basically a quick first pass. Like, does the thing even turn on without smoking?
A sanity check.
Exactly. You run it on newly deployed code. It's designed to catch really obvious major failures right away.
So if the smoke test fails?
You don't bother running all the deeper tests. It saves a ton of time. Back to the drawing board.
Makes sense. And then the other side of the coin. Software is always changing. New features, bug fixes. How do you make sure those changes don't break stuff that was already working?
Ah, yes. Regression testing.
The necessary evil.
You'd call it that. It's basically required anytime code changes. New feature, changed feature, bug fix, you name it.
So you're rerunning old tests.
Essentially, yes. Or specific tests related to the changed areas. The whole point is to ensure the new code hasn't, negatively impacted existing functions.
Protecting your baseline.
Okay, that covers the foundational testing types. Let's shift gears now into section 2. Practical application. How QA gets done day to day.
Right. And a huge part of that is managing bugs once they're found. The bug life cycle.
Talk us through that. What does it look like?
Well, the source describes it starting obviously when the QA finds a bug. They log it. It becomes open.
Okay.
Then a developer picks it up. It moves to in progress. Hopefully they fix it. Then it's resolved.
But it's not done yet.
Nope. QA needs to verify the fix. Test it again. If the fix works, then it moves to closed.
So the QA engineer is involved from start to finish. Identifying, documenting, tracking.
And verifying the fix. Absolutely critical role throughout that cycle.
Now, in a big project, you could have hundreds of bugs, limited time. How does a QA engineer decide what to test or which bugs to prioritize? Good question. It's not random. It comes down to strategy and really business sense.
Oh, how so?
The source emphasizes prioritizing based on business impact, the user base affected, and the complexity of the area.
So the stuff that breaks the core functionality for the most users gets looked at first.
Exactly. High risk, high impact. That's where you focus your resources first. It's about risk management.
Which leads nicely into the overall test strategy. What approach does the source recommend?
It highlights risk-based testing. Same principle, really.
Focus on the risky bits.
Pretty much. You can't test everything all the time with the same depth. So you identify the most critical, high-risk parts of the application and concentrate your testing efforts there first. Then you move to less critical areas.
It's about being smart with limited resources. Efficient.
Precisely. Maximizing the value of your testing time.
Okay, let's talk automation. It's everywhere, but it brings its own headaches, the source mentions.
Ah, yes. Flaky tests.
The bane of automated testing.
Tell us about flaky tests. What are they, and crucially, how do you deal with them? Flaky tests are those annoying tests that sometimes pass, sometimes fail, even if the code itself hasn't changed.
Right. Makes the results unreliable. What causes that?
Could be many things. Timing issues, dependencies on other tests, unstable test environments.
And the solution?
The key solution mentioned is improving test isolation.
Isolation, meaning?
Making sure each test runs completely independently. It shouldn't rely on the state left by a previous test or external factors that might change.
Like a clean slate for every single test run.
Exactly. If test A messes something up that test B needs, B might fail randomly. Isolation stops that interference, makes the test more robust, more trustworthy.
Got it. Makes sense. Now, what about the tools? What specific tools should a QA engineer know according to these guidelines?
The source names a few key ones. For web automation, Selenium is the big one mentioned.
Standard.
Yeah. Then JIRA for bug tracking and managing the workflow.
Also pretty standard.
And Postman for testing APIs, which is increasingly important.
Right. And specifically for web apps, what kinds of testing are expected?
Beyond just making sure buttons work, it mentions functional testing, usability testing, how easy it is for a real person to use security testing, and performance testing. It's a broad scope.
Definitely. It's not just about finding bugs. It's about the overall quality of the experience. Okay, we've covered the technical side, the process side, but QA isn't done in a silo. Section 3, the human element. Collaboration is huge.
It's absolutely vital. QA engineers are constantly talking to developers, product managers, designers.
So what soft skills are they looking for?
Communication is key, obviously. Candidates need to show they can collaborate successfully with developers. Explain issues clearly, work towards solutions, not just point fingers.
Diplomacy skills?
You could say that. And proactivity, too.
Meaning?
They don't want someone who just waits for work. The source looks for examples where a candidate took initiative and maybe improved system performance or made a testing process more efficient, shows ownership.
And staying current. Tech changes so fast.
Yep. They look for evidence the candidate keeps up. Do they read tech blogs, participate in forums? How do they stay sharp?
Okay, so pulling it all together.
Yeah.
What's the profile of the ideal QA candidate based on this source? And what are the red flags?
The ideal candidate really combines all three areas. Solid grasp of testing fundamentals and methodologies, proficient with the key automation tools like Selenium, and crucially, strong problem-solving and communication skills to work well in a team.
The whole package.
Pretty much.
And the things to watch out for.
Yeah.
The red flags.
Well, definitely be cautious if someone lacks a clear, structured approach to testing. If they seem lost talking about basic concepts like QA versus QC or verification versus validation, that's a worry.
They do their homework.
Right. Or if they have very limited experience with essential tools, it suggests they might not be ready for the practical demands of the role.
Okay, one last point, a common question. Coding skills. How necessary are they for QA today?
The source is quite clear here. While maybe not strictly mandatory for every single QA role, especially manual ones, coding skills are seen as a really valuable asset. Hugely valuable, especially with the rise of automation.
Because they need to write the automation scripts.
Exactly. Being able to design, write, and maintain automated test frameworks is a massive advantage. It helps them work better with developers too, speak the same language, makes the whole team faster.
So knowing how to code makes you a much stronger QA candidate.
Definitely. Becoming increasingly expected for many roles.
All right, so we've covered a lot. The core definitions, the strategies like risk-based testing, the tools, the crucial human skills, essentially the blueprint for modern QA.
Yeah, we've really distilled what goes into ensuring software reliability based on what hiring managers themselves are looking for. And it circles back to that idea of validation, right? Meeting the user's needs. Automation is great for efficiency, for catching technical bugs.
For verification, building the product right.
Exactly. But the source implies you still need that balance. You need the human touch for the full picture.
Which brings us to our final thought for you, the listener, to consider. As automation and maybe even AI get better and better at the technical checks, handling more of the verification, how do QA teams make sure the human side isn't lost? How do we ensure we're still evaluating usability, the user experience, the things that really determine if we built the right product for people?
That's the ongoing challenge, isn't it? Balancing the efficiency of automation with the irreplaceable human judgment needed for true quality and validation. Something to think about.